Hello everyone, I'm Xiao Gang. Well, the game Black Myth. Wukong has been released, and I'm still downloading it on Epic, so I'll continue recording the lesson for you. I found a ready-made thread lifecycle online. Everyone just needs to understand the concept. Let's start with the first one. After you create a new thread, it will definitely perform a series of initialization operations, including resource allocation, naming, etc. After these are done, your thread becomes ready. Then, when a task comes in, it can proceed to the next step. Onto the and execute on the CPU. During execution, it may involve interaction with other threads. Or for some reason, it might also get blocked. Once blocked, it just stops here. And at this point, it no longer uses CPU resources. We usually say, you put it to sleep. Or suspend, or make it wait. Then it enters this stalled state. Then after this abnormal state is unlocked, for example, when our sleep time is up, or when this lock is unlocked, or when it is awakened from somewhere else and restored, then it re-enters this central ready state and then proceeds to run. In the middle, it might directly, without the CPU resource, return to this ready state. And then this is a continuous cycle, this process, until this thread reaches its task has been completed or our program ends. At this point, it enters a state of thread death. It essentially exits at the end. So this is a simple introduction to the life cycle of a thread. In UE5, we actually don't need to manage threads because each platform, such as Linux, Windows, or Android, has different underlying thread libraries. If you were to handle this for each platform, creating different thread creation, restriction, and management for each, it would be very troublesome. So here we leave thread management entirely to Unreal Engine. We only define the tasks we do in the middle. Then we define this initialization task, the execution task, the task that has already been deferred. Then you delegate these tasks, throw them to Unreal. Then Unreal handles them for you. You don't need to worry about cross-platform threading. So that's how Unreal currently works. Then we will continue to introduce some basic concepts. And here we actually have some in-depth knowledge, like semaphores, or spin locks, or the level of such locks, whether they are reentrant, if you are from Unreal, switched from Java. When you were working on that Weibo backend, they often deal with this kind of shopping mall, this kind of massive concurrency situations in games. This kind of situation actually manifests quite differently, so you shouldn't forcefully apply other languages or other application scenarios into UE5. Actually, the underlying ideas are the same. For example, things like load balancing. But that doesn't mean every concept can find a direct counterpart in UE5, because UE5 is ultimately designed for game development and real-time rendering. They have their own UE5 threading interaction method. But if you say you don't want to use UE5's threading at all, and you just want to build a set of components for wave-like communication within UE5, you would need to use Radius, you would need to use a database, and all of that is perfectly fine. You can integrate it into UE5 using native C++ scars, or integrate it following UE5's conventions, or simply write it in native C++ within UE5. All of these approaches are perfectly fine. Since we're mainly discussing UE5, we'll follow UE5's threading usage method to explain how it is used. So let's continue with the next part. Let's first talk about what a thread is and what a process is. Then let's open the task manager here, and you'll see right here, there are so many things here. You see, they are all called processes. So we can simply understand it as a program is a process. A program is a process. And under one process, there may be many threads. It may also have only one thread. That is perfectly fine. Now, for example, our UE editor, after it actually starts up, let me show you. Now our UE has already started. You can see this side is the UE editor. And this is our program, right? But actually on this side, you can see here, we haven't paused it yet. Let's find our actor. Let's pause it here. Okay. Then we start on this side. All right. You can see that although this is just a single process, it has many threads here. This is completely fine, no problem at all. Then we can see, let's continue. Here we can see our resource manager. No problem at all. What should we talk about next? So this is the concept of processes and threads. and we often deal with a problem called inter-process communication. So how do we commonly handle inter-process communication? How do we communicate? Let me first talk about the application scenario. For example, I now have a client. I want to access a server, a game server, or access a microblog server, or access a database server. Not a database, it's a database server. Then we can use HTTP for communication. We can also use WhatsApp for communication. Then you can know, actually, we can use our current and this kind of cross-process communication. How else can we communicate? We can use a pipe method. Or we are on the local. If it's all on the same disk, we can write a file locally. Then another program reads this file. These methods are usually applied to, that is, when you use this FMPX and a compiled plugin file, or you use AD2Face. It also starts a server locally. This involves cross-process communication. This situation is relatively complex. For example, our live link, you can take the data, collect it from your phone, and deliver it into UE5, right? All of these are completely fine. This is a cross-process communication. Cross-process communication is relatively complex. In comparison, cross-thread communication is slightly simpler. For cross-thread communication, the method we most commonly use is to reserve a memory area on the heap and then add data to that memory area. We read and write to each other, or we use some queue-based methods for pushing. Okay, these are some basic concepts between threads and processes. Finally, let's talk about what concurrency is and what parallelism is. This is also a classic concept. When I learned it before, the teacher often emphasized it. What is concurrency? What is parallelism? Parallelism is actually very simple. For example, here is our main thread, and here there are many threads. They are all performing various tasks. For example, this thread, it is an IO thread. It is responsible for writing data to the local system. For example, if you have save files or something. And here is the audio thread. Audio thread, it is responsible for pushing audio resources to our Windows. How to a device, for example, your speakers or something. Right. This group also has the audio thread. We can also capture the microphone and such. Actually, these are all parallel threads. So what is concurrency? What is concurrency? Concurrency is actually at a single point in time, executing multiple tasks simultaneously. That is called concurrency. So everyone should distinguish between concurrency and parallelism. They are actually two different concepts. Don't confuse them. Concurrency is at one point. We initiate multiple tasks. Then these multiple tasks start executing. And parallelism means that between them, they execute simultaneously as a concept. Okay, this might still be a bit confusing. Actually, it means concurrency. It could be that at the same time, multiple things happen, and they still execute in this way. But parallelism means at the exact same moment, all these things are happening. And concurrency means it could also be on a single, constantly switching back and forth. It looks like they are executing simultaneously, but in reality, they might be switching back and forth. Jump like this, jumping like this to go, moving forward. And parallel means they are truly at the same moment. These actions are all being executed. You can simply understand it like this, okay? Then let's continue. When talking about concept here, I'll also go over the concept of threads with everyone, so that later we can directly write our practical code. Alright, let's think about why the concept of threads exists. Why does the concept of threads exist? First of all, let's talk about a thread. It constantly switches between threads, and its creation and destruction are very performance intensive. So if every time we do a task, we create a new thread, and this task is particularly urgent, I hope that after I click, it executes immediately. But you tell me, after you click now, I need to create a thread. I have to go through the motions and then apply for resources, and only after approval can it execute. That won't work. So can we? In this way of trading space for time, I prepare all the resources in advance. Then you come in directly and you just start doing the tasks. So there is such a situation. And then at the same time, whether it is convenient to manage you. For example, if I have one task, I create one thread. Now, if I create 500 tasks at the same time, then wouldn't you have to create 500 threads? That kind of design pattern is unreasonable. So the normal design pattern, I have 500 tasks, but I only create 10 threads. these 10 threads, they are essentially queuing up to execute tasks. So this is a relatively good and reasonable design approach. In fact, if we draw a diagram, it looks like this. That is, before the game starts, before we have begun the game, we have a large pool here, a large pool. Inside this large pool, we have 5 threads, A, B, C, D, and E, and they are all currently in a dormant state. They are not occupying CPU resources. They are simply sleeping. Now we have tasks numbered 1 to 500, right? So this is generally a queue. Then we have these 500 tasks. We just added them in sequence. Then the thread pool, they will check this queue because this thread pool is specifically handling these 500 tasks. For example, these 500 tasks are player login requests. Then this thread pool specifically handles these login requests. Then they distribute these tasks among A, B, C, D. After they finish, they fetch again. After finishing, they fetch again. This is how the processing works. Okay, then at this point, another problem arises. So among our 500 task words, right, we have an SBIP. Then at this point, there is a priority. There are low and high priority situations. Then this class might have another queue. Each time we first check if there is anything in the high priority queue. Only after the high priority items are executed do we then execute the low priority ones. This is a very good way to handle thread words. When recycling this thread word, it actually happens when the game ends. When the game ends and the main thread starts to exit, we then recycle the contents of this thread word. And in fact, UE5 does it this way too. UAE Weave has many thread terms. Later, we can see that threads are divided into many categories. There is the task graph, and one specifically for handling audio, and thread terms specifically for handling I/O. Okay, actually, this is a simple concept of thread terms. If we go further into it, it becomes more complex because after this task is executed, it may need the main thread. For the main thread to spawn an actor, then this involves the concept of Unreal Engine. Because you know our actor, it must perform line modification and query on the main thread. After it finishes executing, a main thread task can be pushed here. We like to call it a task. Then this task is pushed to our gamesway. Gamesway will pull this task every frame to see if there is any task it needs to do. Once it finds a task, it will generate objects in the scene during that frame, performing additions, modifications, and queries. Okay, that's the basic concept.